detention, not fun.
It was so much fun, wasn't it?
Yeah, detention. No, that's not my favorite thing to do.
I'm sure it is.
Okay, we are going to start with question 11, which is the first free response question. So if you can get yourself there. Take a second to get yourself to question 11. In an article in the winter 2003 issue of Chance magazine, it reported on the Houston Independent School District's Magnet Schools program. The data on an applicant's ethnicity and their likelihood of admission is summarized below. All right, so we have this chart here. So if you take a look, we can see how many Black Hispanic people were accepted, how many were waitlisted, how many were turned away. Turned away, I think, is a nice way of saying rejected. We can see how many Asian students were accepted, how many Asian students were waitlisted, and how many Asian students were turned away, rejected. Same thing with white students, how many white students. At the very bottom, we have our totals for how many total people got in. So a total of 931 students were accepted into a magnet program in Houston Independent Schools District. 524 students were turned away from the school district. We also see how many of the applicants were white, Asian, and Black Hispanic. And the total number of applicants, of course, is right here. There were 1,755 total applicants. Great. Next note. If you want to find any of these probabilities, you just need to take a cell and divide it by 1755 to find the probability of that cell. Okay. So if I had unlimited resources, I kind of do, but I'm not going to do it. But all I would really need to do is take every cell, divide by 1755, and I would get a bunch of percentages. For rounding purposes, I'm not going to do that. We'll do that at the end. Next note. Notice here where it says let. Okay, I'm going to be using 6 different abbreviations. If you're using abbreviations, you need to define them. Okay? Maybe I should put that here as a comment. Comment. Any abbreviations that you use must be defined. So for example, if I said probability of W, and I didn't specify what W stood for, I would expect to lose points. You have to say what these are all standing for. Okay, let's see, the probability of W and TA, let me read that question. Estimate the probability that a randomly selected applicant would be white and turned away. Okay, white and turned away. The comment here is when you see the word and, you can just read the number from the cell. So white and turn away is 359 right over here where the cursor is, where the mouse is. So that probability is 359 out of 1755. Your calculator will do a good job and say 2046, 2046. Oh. 2046. No. But that was just last year, or that was just the spring.
2048 again.
Oh, it was 20. Really close. Okay. B. We want to know the probability of. Oh, actually, I should read it. Estimate the probability that a randomly selected applicant would be white or waitlisted. Asian or waitlisted. Okay, so we have here it's the probability of Asian or waitlisted. Don't take any chances. Write down the formula. Asian or waitlist is probability of Asian plus probability of waitlisted minus the probability of Asian and waitlisted. Okay. One thing that I don't want you to do is to pretend that these two are independent and just do a multiplication. That's really a bad idea. Don't assume things are independent. This formula works even if the Asian and waitlisted are not independent. So there's no reason not to use it. So comment. Do not just multiply. Or no, do not just add probabilities. Don't, i.e., don't assume the outcomes are disjoint. I don't know what dijoint means, but I know what disjoint is. Dijoint. Okay. Questions. Letter C. Estimate the probability that that be accepted. What? What did I write here? Estimate the student that estimate the probability that a student is accepted if he/she was Black Hispanic. Okay, that reads to me like it is a conditional probability. So the question, well, the reason why it sounds like it's a probability, my words are not working today. Conditional probability is because we have both events here. We have accepted and we have ethnicity. Those are the two different things that we're looking at. They're both mixed up in the same question. So that really means that we're probably looking at a word C. Why is this word always I just said it.
Conditional.
Conditional, thank you. Conditional probability. So the question is, do we know that the student is accepted already, or do we know that the student is Black Hispanic?
Black Hispanic.
Okay, we know that the student is Black Hispanic. So we are given Black Hispanic. We're trying to figure out the probability that they're accepted. Again, if you feel more comfortable doing it this way, you can just go ahead and use the formula. That's the probability that they were accepted and were Black and Hispanic divided by probability of Black Hispanic.
On the test, will we be marked down if we don't write like over 1755?
No. Be careful though. Okay, so we have, what's the probability of accepted and Black Hispanic? It's intersection, it's an and, so you can just read it from the chart. Accepted Black Hispanic, that's 485 out of 1755. Divided by probability of Black Hispanic, that's 517. Black Hispanic, of course, is the row total. 517 out of 1755. That gives me 0.9381. I'm still seeing people with probabilities to 2 decimal places or 3 decimal places. Please, 4 decimal places. I don't know how many times I need to remind you. It's kind of pointless to remind you if you're not listening anyways. So, okay, and that's that. A couple of really good questions. Did we need to actually divide by everything by 1755? Well, mathematically it works out fine, but don't take that as it's always going to work out mathematically correct that way. Okay? So make sure you're making a good analysis of the numbers before you decide to not worry about the 1755. Let's take a look at D. Estimate the probability that a student who was not white was either waitlisted or turned away. Wow, that is a lot of things there. Okay. Sounds like conditional to me again. So do we know that the student was not white, or do we know that the student was waitlisted or turned away?
Not white.
We know that the student was not white, so that's why we're putting that second here. So we want to know that the probability that the student was waitlisted or turned away. Okay, so that's where we left off during period 1. Let's finish this up now. Let's write our formula here. That's equal to the probability that a student was waitlisted or turned away and they were not white, divided by the probability that the student is not white. Okay, so we're looking for we're looking for cells that are either waitlisted or turned away, and cells that are at the same time are not white. Okay, so waitlisted or turned away are the second two columns. Not white are the top two rows. So these 4 cells where I'm hovering right now, these 4 cells are not white and not accepted, or not white and waitlisted or turned away. So what is that probability? 32, 49, and 133? 32, 49, did I say 133?
Yeah.
133. Oh, there's also a 0 there. Maybe I should put that in also. Divided by 1755. And that'll give you the probability, that first one, waitlisted or turned away and not white. Divided by not white. How many students were not white? 517 and 292. 517 and 292 divided by 1755. I feel like over parenthesising this. That's my denominator. This is my numerator.
You did the wrong parenthesis.
I did. I did. All right, so what do you think? Is one note going to help or not help? Oh my God, I can't believe one note. Sometimes this thing is smart. Is that what I came up with in the answer key? Yeah? Hallelujah, saints. And that's it. How do you feel about that question?
I don't like the last one.
Yeah, the last one's a little bit of a brain scrambler. Yeah.
Or the waitlisted,
Mhm.
or waitlisted, turned away.
Turned away. Yeah.
And not white.
Mhm.
If we found waitlisted or TA and then multiplied it by not white, would that still work?
No, you don't want to do that because that assumes independence.
Okay.
Sure.
So if we do it, we find waitlist or TA first.
Hmm?
So we find the probability of waitlisted, or so no, not probability. We find.
The cells.
So how would you do waitlisted or TA and not W again? I'm still not understanding. That one intersection.
Sure. Are you ready? Okay. So waitlisted or turned away are these two columns.
Yes.
Okay. So basically, you're looking at these two columns and not white. Not white are the top two rows. So we're looking at the intersection between the first two second two columns and the top two rows.
Okay. Okay, got it. So yeah,
Okay, let's get to number 12. Number 12. A Approximately 30% of the calls to an airline reservation phone result in a reservation being made. Wow, that's not a lot of information to go on. Hopefully they're not going to ask anything too in-depth. Let's see. Suppose that an operator handles 10 calls. What's the probability that none of the 10 result in a reservation?
7 to the 10.
Yeah, that's just 0.7 to the 10th power. 0.7 raised to the 10th power. Because the first call is not for a reservation, the second call is not for a reservation, the third calls, and the fourth call, and the fifth call, and the sixth call, etc., etc.
That it's independent, though.
Yes, that assumes that we're independent. I actually don't know what this number is. Let me cheat.
How does one not do that?
0282. Okay, so let's let R be equal to the phone call ended in a reservation. So that means the probability of RC the first call and the second call and the third call
Those 2 dots I thought.
and the last call
Are we allowed to do that on the test?
yeah, absolutely. That's equal to that. Assuming, and this is a good point,
That's actually the next part, so.
assuming the phone calls are independent.
If they're dependent, there's no way of actually calculating it, right?
Yeah. If they're not independent, then we don't have a way of calculating it exactly.
Did you do 0.7 to the 10th because 0.7 is the probability that it's not in a
Exactly.
situation?
Exactly.
Yeah.
What assumption did you need to make? Yeah. The phone calls needed to be independent. And like you were saying, if the phone calls are not independent, we have no way of figuring out any of these probabilities. C, what's the probability that at least one phone call being made results in a reservation being made? One phone call out of 10?
+2 +3 +4.
Okay. So whenever you see that,
Oh, it's just 1 minus 9. Right?
yeah,
Yeah.
whenever you see at least one. Okay.
One but none.
This is the complement of none. Okay? Calculate the probability of none and find the complement. So what's the probability of at least one?
1 minus 9.
Is equal to 1 minus the probability of no reservations in 10 calls. Right. And we calculated that already, didn't we? No reservations being made in 10 calls is 0282. So there's a 97% chance that at least one reservation is going to be made. I'm going to cheat and make sure I did this right. Yeah. How frustrating. These are in 3 decimal places. Okay. Questions on 12, that's a pretty easy one, right? It's not bad. See, they don't all have to be difficult. There's some easy ones here. I need to keep track of time. It's going to sneak up on me. What time are we?
Yeah, like 7 minutes.
You have 7 minutes?
Yeah.
All right, so we're just going to chop it off here then, okay? That's like the worst words I've ever heard, actually.
We're gonna truncate.
We're going to truncate.
So much more.
Even though you always run in stats.
Even though we round in stats, we're going to truncate.
Why do we truncate in calc?
I don't know.
This couch is math.